So this question asks, based on percent error, which student's trial was the most accurate? Which student's trial was the least accurate? So there's two things that this question, well, there's one thing this question is asking, but so percent error, we know, is defined by this equation, which is 100 times the absolute value of the error over the accepted value. And this question is asking about accuracy. And accuracy is going to be defined as how close a measured value is, or an experimental value, is to an accepted value. So the way that we can approach this problem, because it asks based on percent error, if we take the average of each student's error, at least the absolute value of each value, and then calculate the percent error, we can kind of see which student is going to be the most accurate. So we'll call student A is going to be blue. Okay. So if you take the average of the errors, and again, we're using absolute values. So percent error is going to be equal to 100 times the absolute value of 0.0267 over the accepted value of 1.59. And these are both in grams per centimeter cubed. I forgot to write this up here, grams per centimeter cubed. And so if we were to calculate student A's average percent error, we get a value that's equal to 1.68%. We'll call student B green. So now student B's percent error is going to be equal again to 100 times the absolute value of the error, which if you take the average of 0.19, 0.09, and 0.14, all in absolute value, you get an average of 0.14 grams per centimeter cubed. And if we divide this by the accepted value of 1.59 times, or with grams per centimeter cubed, we get an error of 8.81%. And we'll call student C is red. So C's percent error is going to be equal again to 100 times the average of all of these errors in absolute value, which is 0.11 grams per centimeter cubed. And this is going to be over 1.59 grams per centimeter cubed. And so student C's percent error is 6.92. So now, again, the question asks you specifically which student is going to have the value that is the most accurate and which is the least accurate. So now we can look at these calculated values and see that student A has the most accurate because they have the lowest value for percent error. And now B is going to be the least accurate because now they have this largest value of error. And if you look back at the original data, you can see that student A's errors are all relatively small, 0.05, 0.01, 0.02, versus student B, which has 0.19, 0.09, 0.14. And so you can see that student A is the most accurate, student B is the least accurate, and student C is somewhere in the middle, but nowhere near as accurate as student A.